Welcome to Freedom. My name is Chuck Cox. In this video, I'm going to provide you an overview with our Process Automation Toolkit, or PAT, and also demonstrate its functionality. Before we dive into it, though, I want to answer 3 questions for you. What is the PAT? How do I get it? And how do I connect it? If you use service monitors to test and align radios or troubleshoot, you know that many of the tasks that you do are very repetitive. And you've no doubt asked yourself if there was a way to automate this process. This is where the PAT comes in. Without having to write a single line of software or code, you can now, using this drag and drop interface, create scripts to automate your radio tests. To obtain this software, you can simply go to our website, select from the menu Upgrades, and scroll down until you see the optional PC software. There are 2 items on this list. Our remote front panel, which I will be using in this video to remotely control and show the screen of my instrument, and the Process Automation Toolkit. Both of these are freely downloadable from the website. However, in order to use them, you do have to have a certain option on your service monitor, and I'll talk about that in a little bit. So you would download the Process Automation Toolkit and install it on your laptop or computer, and then you would run the program. Once you've downloaded and installed it, now you will need to connect to the instrument. This is done by creating a network connection. The instrument has an Ethernet port. You can connect one of several different ways. You can connect directly from your PC to the instrument with an Ethernet cable. You can connect the instrument to a network and control it through your network. You can also connect your instrument through a Wi-Fi network by adding an access point. Or in my case, I have an access point, but I'm connected directly from the laptop to the instrument over Wi-Fi. On this screen, I have the remote front panel application running in the upper left-hand corner and the Process Automation Toolkit in the upper right-hand corner. To determine the IP address of your unit, if you need to, you simply press Settings, Network Setup, and you can see here that I have DHCP turned on and I've been assigned an IP address. But you may not have to even have this IP address. Let me show you. The Process Automation Toolkit, as soon as you open it, will search for an instrument. And when it finds the analyzer, it will tell you at what IP address it was found. If for some reason it does not find it and you know the IP address, you can click in this field and put in the IP address. Once it starts to communicate with the instrument, it will show you the model number, the serial number, and the current firmware version. Be aware that certain versions of PAT require a minimum level of firmware on the instrument. Now, while we're talking about this IP address and searching for the instruments, you can have multiple instruments on the network and control each of them individually. Once it finds your instrument, it will continue to search for other instruments, and you can see the search button is green. I can stop this search if I want to by clicking the button, and it becomes gray. There's also a button that shows you a list of all instruments that are found in case you have several instruments but you want to control one specific instrument. Now that PAT has found your instrument, it's time to start writing a script. There are three basic concepts that you need to understand. Our end goal is to create a script or list of steps that can be sent to the instrument. This script will be built in the right-hand window over here. In the left-hand window are items or commands that can be added to the script. There are various forms of commands to control the instrument or analyzer, and you'll see that these map very much to the user interface of the instrument. You can change the mode, such as monitor, generator, duplex. You can go into instrument settings, test, and you'll be doing most of your work in the zones. As most of you probably know, the user interface is divided into 4 zones. You can see here on the left the RF zone, the audio zone, the display zone, and the meter zone. You can navigate between the zones using these vertical soft keys, but I strongly encourage you to get used to using the shortcut keys located here, as shown by a white outline around the number keys. Pressing one of these numbers, for example, the number 1 will take you to the RF zone, the number 4 to the audio zone. Now this is the layout for the 8100. The R8000 has the RF zone in the upper left, the audio zone in the upper right, display zone across the middle, and meter zone across the bottom, and that's reflected with the white outline. So this command, mode command, allows you to switch between the modes. But most of your work will be down in the zones. We have the RF zone, as we stated, the audio zone in analog mode, the display zone, and the meter zone. When we go into digital modes, we then have access to the various digital modes. We have a few other types of commands that we'll cover in more detail, but I'd like to explain real quickly what they are to you. Automated tests are pre-built scripts that you can use inside of your own scripts. You can also save your scripts that you create and then use them inside of other scripts. External devices. At the end of this video, I will show you how to actually control an external device, such as a relay, to activate the PTT line on a radio. Finally, operators. These operators allow you to add intelligence into your scripts. For example, you can pause and prompt the user, for example, to key the radio. Or you can put in if, then, else statements, and we'll cover that as well. Okay, so we have commands that can be added as steps into the scripts. Let's add our first command. Let's go and add the mode into this script. As you can see on this next slide, there are 2 different ways to add a command. You can either double-click it, or you can highlight it and then click Add. I have 2 of those now, so I'm just going to go ahead and hit Remove. Now that we've added the command, you can see the parameters that apply to that specific command. In this case, the action is a get, and so the instrument will be queried and respond with the system mode that it's in. As a matter of fact, let's send this command. You may have noticed when we added the command, this manual command entry box populated to tell us exactly what's being sent to the instrument. This is the monitor and control programming language, but again, you don't have to know that. The PAT does that for you, but let's send the command by pressing send. And notice that the instrument came back and said that it was in monitor mode, as we can see up here in the upper left-hand corner. We want to change the action to set. So I select it, say set, and in this case we want to test the receive of a radio, so we need to generate a signal. So now I have set to generate. Notice you can also do different things based on whether it comes back with an error or not. We also have a default wait period, but you can change that if you'd like. Let's now send the command and see what happens. You can see now the instrument is in generate mode. We're generating a carrier at 500 megahertz minus 50 dBm from the RF in-out port. Okay, now that we also have a command, we can edit its description. In this case, I single-clicked on the description, and I can go in and make the description more descriptive. In this case, I want to say system mode to generate, so I can just see that by reading the script descriptions. Let's add another command. Now that we set the correct mode, we need to make sure that we're generating from the right port. So how do I do that? On the instrument, I would go into my RF zone by pressing the number 1 key. So here I'm going into the zone menu, RF, and I'm going to add a command that goes to the RF zone. Let's run that command. There we go. You can see the RF zones highlighted. Next, we need to go to our generate port and add that command. It's a get. We need to change it to a set it to the RF in and out. And let's go ahead and edit our description to say RF in and out. Okay, and let's run it. Of course, it was already set to RF in and out. Okay. Now I want to show you a couple of other ways you can edit the script. You can drag and drop to change the order of the script by clicking on an active or selected step and then moving it up or down. In this case, now the generate port is set before the zone, so I need to switch it back. There we go. Another feature is the ability to right-click on a selected step, copy, right-click in another spot, and click paste. And now you can see that there are two of the same exact commands. Since I don't need the second one, it's highlighted. I'm going to select remove. You can see that there. Okay, and we already talked about being able to send commands. So let's build up a script to test this radio that I have connected. It's an analog VHF radio with a PL tone. So I need to set the frequency. So I'm going to go to RF, generate frequency, add, set. In this case, I'm going to set it to 147.3 megahertz. And since I want to test its sensitivity, I'm going to find output level. And again, this is the same way as if you were operating the instrument here, output level, add, and I want to set the output level to -110. Okay, let's run the frequency step and make sure that it works. So I'm going to hit command, send command, and you can see the frequency has been changed. Now you can't see my radio, but on the radio I have a receive light, so I am getting a carrier. The squelch is not opening up because I have a PL, but there is a carrier there. Now go to output level, send that command. I still have a light. Okay, now I want to be able to open the squelch and hear a tone. So how do I do that? On the instrument, I would press the number 4 to go to the audio zone. So let's find the audio zone. And let's add that. So now it will switch if we run that command. You can see that it switched to the audio zone. The next step would be to put a 1 kilohertz tone on this carrier. So I'm going to take and set the 1 kilohertz level. Set. It's a 25 kilohertz channel, so I'm going to set it to 3 kilohertz. deviation, then I need to turn it on. So if I send my command, fixed 1 kilohertz, level set to 3, and let's add the mode, set command to continuous. Alright, so let's send, and you can see 3 kilohertz deviation, and send, and now you can see that our fixed 1 kilohertz is on. Now we can't hear it because the radio is still squelched, so the next step would be to add a PL tone using our synthesizer. So our format is already set to PL, so we'll simply have to set the synth level, add, set to, let's set it to 0.6 kilohertz, and send the command. There we go. Then we need to turn it on, so that would be synth mode, set to continuous. Let's go ahead and send it. Now you can see it's highlighted in green, but we're sending out a 1Z, not a 5Z, which is what the radio is expecting. So now we go up to PLCTCSS, add, set to, go down and find 5Z. Now as soon as I send this command, the squelch should open up on the radio and we should hear our 1 kilohertz tone. Let's try it. There you have it. Now I'm going to manually switch back to monitor mode so we don't have to hear that tone. So now we have a complete script which is able to set the instrument in such a way to test the receive on this channel of the radio. So now we would like to execute this script, and so I'm going to go reset this instrument back to factory configuration so that we can watch it while it works. We're loading factory configuration. In just a bit we'll talk about how we can save this script and then reuse it in other scripts. The way that you run a script is using these buttons at the bottom. You'll click execute to run the script. You'll have the ability to pause and continue, and you can also stop a script. As the script is run, we will see the commands and results appear down here in the lower right hand corner. Our instrument is back to factory default. So let us execute our script. Here we go. It's been set to generate mode. It's gone to the RF zone, changing the frequency. We have a 5-second delay on changing the frequency, output level, audio, and there we go. So by simply running this script, the instrument was set up to test the sensitivity of this radio at one frequency. And again, there's no limitation here. You could then switch to a different frequency and do that in a fully automated fashion from there. Okay, let's run the script again just so I can show you that you can pause. So here we go. The script is running. I hit the pause button. At this point, execution is paused. The button turns green for continue. I'll hit continue. Then I'll show you, you can hit stop. It'll light up red until it finishes the current step and then finish. And so now let's talk a little bit about test results. Let me take us to the next slide. And we talked about how the results show up here in the lower right hand side. Here we go. Now the test results. In the test results you get date and time, information about the analyzer, and about each step that was run in the script. There's also an operator field, which if you click up here to select it and then click again in that field, you can add a name, and this will be saved into the file. And so let me show you. When you hit save, I'll move this out of the way, you'll get a dialog box, and there's a special folder just for PAT test results, and they are saved in a .csv format. You can see here comma separated values, which can be loaded into Excel. Since I've already saved it, I'm just going to cancel. You can also open up test results from previous runs and see them here, which is what our next slide talks about. Okay, so we've run a script, but we haven't saved it yet. Let's say we're satisfied that this is running the way we want to. We want to save it by clicking on Save. You will be taken to a dialog box. Again, this is a special folder called Automated Tests. In here I've created an analog folder and an RX test. I'm going to overwrite my RX test. Once you've saved it, notice up here it gives you the name of the script. Another thing I want you to notice is that inside of Automated Tests, there's now a command, RX test, which I could then add just like any other command. Oops, let's select RX test and add it. And so it's added my entire script as a subscript. Obviously I don't want to do that right now. But that's the ability to nest scripts, which allows us to do things like, well, let's clear out this script. We've got it saved, so let's clear it. And let's load a script in analog that I created that does both the receive and transmit tests, each of which are subtests. So here you go. It runs the RX test, then it waits for 5 seconds, then it prompts the user to key the radio, then it runs the transmit test, and then it prompts the user to unkey the radio. So that's the power of nested scripts. You can create basic functionality that can then be added on. You can create folders inside of Automated Test to organize your scripts, and they will show up here in your programmable actions. Very powerful functionality. There we go. You can reuse a test as a nested script. Okay, so now on to a little more elaborate functionality. Let's talk about operators. Down at the very bottom of our list, we have operators. For this, I'm going to load my transmit test that I created previously off camera. There we go. Now this is very similar to our receive test, only now we're going into monitor mode. We're going to the RF zone. We're setting the RF in and out port. We're setting the frequency to 147.9. Then we're reading the power level and we're reading the frequency error. Very simple script. Now, something you've probably noticed is that this is assuming that the radio is already keyed up, and that's why in my RX-TX test I had a prompt to key the radios. But let's add those prompts here inside the script. So in order to do that, we come to our operators and we find the pause operator. Let's add a pause. Again, we're going to click on it and type in our prompt text, key radio. Enter. Now I want that to happen up here, so I'm going to click and drag right before we set the frequency, because we know it's going to pause for 5 seconds after it sets the frequency. So now it should do everything up to that point, prompt us to key the radio, and then we need one at the end to unkey the radio. Well, let's copy and paste. A good example here. Copy, paste. Let's come in here and change the prompt to unkey radio. So let us run this script and see how it works. We'll hit execute, It'll run the first 3 commands, then it stops, prompts us to key the radio, which I'm doing now, and I press continue. We can see our signal over here, our power measurement, and our frequency error, which will be read back. Now it prompts me to unkey the radio, hit continue, and here's our test results. So I can see that on this date and time, using this service monitor, at this frequency, I measured 37 dBm and a frequency error of 25 Hertz. So now you understand how to insert prompts into your scripts. And the next thing we're going to talk about is if-then-else statements. I've pulled up an example of the use of the if-then-else operators. This is from one of the pre-built scripts related to Tetra TMO. I'll walk you through the syntax here real quick, and then we'll create our own if-then-else statement using the transmit test that we created earlier. You can see here it says if line number 1 equals Tetra TMO. What is line number 1? Current test mode. So we read the test mode, and we're saying if the test mode is Tetra TMO, then what? Then go to line 6. That means we don't need to change the test mode. So go to, and line 6 is the rest of the script, the beginning of the rest of the script. However, if it was not Tetra TMO, then set the current test mode to Tetra TMO. So again, this allows us to test for a condition and do something conditionally. So let's apply that same logic. Let's say we know that changing the monitor frequency causes the script to pause for 5 seconds. Let's check to make sure if the frequency is already set, not to set it again. So let's come up to our script. So first of all, we need to read the monitor frequencies. So we'll go again to our analyzer commands, to the RF zone, which we're already in the RF zone at this point. So then let's go down to monitor frequency. Okay, and we're going to put this above. So right after we've asked the user to key the radio, we're going to go get the frequency. Then we're going to go down to our operators, select if line number. So which line number do we want to look at? We want to look at line number 4, which is where we got the frequency. And then we want to say equals 147.9 megahertz. Then we want to go 2 lines. We want to skip over, and we'll go down to a line below. We don't know what that line is yet, because we want to put an else in here, right here. So if it is not, we're not already at that frequency, it's going to run the else, which is going to set the frequency. So our go-to line needs to go to reading the input level, which is step number 10. So we'll go up here, put step 10. There we go. So now when we run this, it should set the mode to monitor, go to the RF zone, set the port to RF in out. Again, we could make that an if-then statement. I'm going to ask the user to key the radio, check the frequency. If it's already set, then we'll jump down and read the input level, read the frequency, then unkey the radio. Okay, let's run the script and see how it works. Okay, I'm keying the radio, continuing, and you can see monitor frequency, it read it, and then it skipped right on down and unkey the radio. So you can see that it read the frequency and it didn't set the frequency. It jumped right on down to read input level. You know, we can see that over here in the test results. So that it's a little more complicated syntax-wise, but it's very, very powerful. I hope you'll be comfortable enough to use that in your own scripts. Our final topic is controlling external devices. So as we've been working through this TX test, we've had to learn about how to prompt the user to key the radio. Now, wouldn't it be nice if the Process Automation Toolkit could actually do that automatically? Well, you can, using something like this. This is a USB controlled relay. We provide the ability to control a relay, and if you wire that relay to the PTT line of the radio, you can actually key and unkey the radio automatically. I have some pre-built commands for that here under external devices. So let's replace this prompt key radio with activate PTT. There we go. And then unkey radio, we'll remove that and we'll add in deactivate PTT. There we go. I don't have this hooked up to the radio, but basically when it would come to that activate PTT relay, the relay would close, activating the PTT on the radio and continuing on the test. So you can see here that this script could run completely without user interaction, and if I ran the receive and transmit with the push of one execute button, I could run a full receive and transmit test of this radio. Now, doesn't that sound like a great way to save some time? The way these external device commands are created, I'll show you real quick. External devices, then I press settings, pops up a new window, and let me show you activate PTT. Simply tell it which COM port. It's a virtual COM port device. Most of the settings are default settings are what you'll need. And then the command format from the manufacturer of this relay. The information was that if I sent a hex 01 or an ASCII, well, that doesn't work, that would close this relay. And if we select deactivate, if I send a hex 02, that it will open the relay. Again, you can create your own to either control COM port or virtual COM port USB devices. This could be relays or other RF relays, so you could actually switch in and out cables or activate lines, or you can also control IP devices. Here's an example: IP address, port, and then the command that's being sent. This is a little more advanced, but if you need assistance with that, we'd love to work with you. This concludes the video, and I hope you'll agree with me that the Process Automation Toolkit has tremendous potential to help automate routine, repetitive tasks, eliminate human error, wasted time. We would love to work with you. Before we go, I'd like to point out a couple things. You can go to the website and download the Process Automation Toolkit even if you don't have one of our instruments or don't have the Process Automation Toolkit option. The only limitation you will have is that if you don't have an instrument, you won't be able to obviously talk to the instrument. If you do have an instrument without the option, you will be able to build scripts and run the steps individually, but you will not be able to execute an entire script. So thank you for watching, and I hope to see you again in another video soon.